Paparazzi, Genady. This question arrived in Codechef-March long challenge. This is a really interesting problem. Let's just dive into this problem straight away. So the question says the young but promising paparazzi Genady wants to finally become famous. To do this, he wants to take a picture of a new superstar during her walk in the mountains. So he'll have to take a picture to become famous. Now it is known that the star's path in the mountains contain n sections. Now here is the point the question starts. So there are n sections that the star would take. For each valid I, the ith section is a vertical half open interval with coordinates x equals to I and y ranging from 0 to h of I. So it says that basically this. Yeah. So here for any x equals to I, the y ranges from 0 to the maximum of this point is h of I. Okay. So for each valid I and j, our hero can take a picture. Now this is the question, that when Paparazzi Genady will be able to take a picture of the star. So he'll be able to take a picture of the star located in the ith section of the walk when he is in the jth section, only if he can see the interval, only if he can see the star. So he can click a picture if he is in the jth section and the star is in the ith section. So suppose say star is somewhere in x equals to I, Paparazzi Genady is in this one, say x equals to j. So he can take a clear picture of the star if he can clearly see the star, means there are no other. Okay, we'll read the next part. It says that and each of k which lies in between I and j. So this is the k which lies in between I and j. This the half open interval that makes up the kth section must not intersect the line segment this. It means that this must not intersect this line segment. This shouldn't intersect, and clearly it is not intersecting here. So Paparazzi Genady here will be able to take a picture, right? Now Genady is a paparazzi and not a programmer, correct? So he asks us to determine the maximum distance that he can. So we have to maximize the distance. We have to maximize j minus I. That this is our objective of the problem, right? So let's quickly take a look about the test cases and then we'll see through the examples of it. So the first line of the input says, yeah, the number of test cases, then it's the integer n, and then height are given accordingly, right? So in the constraints it's okay, in the constraint this is very important. N is 5 into 10 to the power 5. So when n is 5 into 10 to the power 5, you need to understand that you have to solve the problem somewhere from O of n log n, and you can also solve it in O of n or less, but you cannot cross O of n square. That would give you TLE, so you have to be careful while solving this. Now there are few subtasks also for lesser n. Now let us look at the example. Let us look at the example test case 3, because the graph is being provided here. This is the test case 3 2 5 3 2 4 3. All right, so let us look at this. So now let us look at the example test case of this Paparazzi Genady problem. Given test case for this is, these are the heights. So these are the heights of our n sections 3 2 5 4 2 4 3. As you can see in this graph, these for each x equals to I, the heights are given. These are all x equals to I, and for each of them the heights are given. Now remember the question said we have to find maximum of this j minus I, right? The maximum of j minus I, Paparazzi, from where Paparazzi will be visibly able to take a photograph of the star. So in this example, what would be the maximum value? Now see this red line from 5 to 3, this one. From if Paparazzi Genady is sitting here at x equals to 7, Paparazzi Genady will not be able to see the star as x equals to 6. This section ranges from till 4, x equals to 4. The height is 4, so it basically, you know, prohibits the vision of Paparazzi. But if Paparazzi is sitting at x equals to 6, if you join the line segments, he clearly can see it as no other k. Remember they said k from I to j, so no other k is cutting the line segment this from 4 to 5. So no other line segment is cutting, hence Paparazzi Genady can take a picture, and this is the maximum of all that this is the maximum distance from where Paparazzi can take a picture. Because see, from here also Paparazzi can take a clear picture, from here also Paparazzi can take a clear picture, but this from 6 minus 3 is the maximum, and hence in the output console they have written 3. This is the output of it. Like I said, what you can't do is take a order of n square approach for the original constraint subtask. But there are two other subtasks given where your n does not exceed 500 and does not exceed 8000. Here you can safely take a order of n square approach. Now to solve such a question, the approach is not, very complicated. You just have to have a sound understanding of the two pointer approach. If you take two pointers, say first and second, if these are your two pointers, all you need to form is an equation. So if my height of first is 3 and height of second is also 3 in this case, the equation forming will be y equals to 3. So for every value that lies, for every x equals to I that lies in between these two pointers, we need to check that is there any y that exceeds this. So we can clearly see that this y exceeds this, and also this is equal. So we can't have a clear picture of the Paparazzi, of the star, right? So Paparazzi sitting here, star sitting here, we can't have a clear picture. So we just decrement the second pointer, we come here and we do the same. We form an equation, and for every point from x equals to 2 to x equals to 5, we see that for every x equals to I, does this maximum height crosses the point value of it. We'll have to use a double order float. If we take int, that will just round it up. So we'll just have to check for each of the intervals, for each of the values, and you can store the difference d equals to j minus I and keep maximizing it. Suppose say your max sum is this, so max equals to, so sum equals to, right, sum equals to max of this d comma sum. So you can just use this, and you can keep updating your d and check for each for the pointer approach. So similarly, but like I said, this is a brute force approach, a naive approach, because here if you just go to the third subtask where they provide you with the original constraints, where I said it is 10 to the power 5, you would get a TLE if you solve by this method. So I'd encourage you to solve the problem, at least the first subtasks, and then have a order of n log n approach for the Paparazzi problem. That would solve your problem. And thank you so much for listening. Subscribe to my channel. There is going to be a huge amount of content coming up on competitive programming and coding, a lot of